Hello, this is Roger Miller. The idea, I'm just creating if you're new, just creating a series of videos here so that trying to smaller pieces, just kind of go over some basic ideas that I have. And we'll just jump right into this. So kind of building off some of the other videos, if you haven't seen them, the idea that as an object is, the idea originally started with a box fan that was out of balance, it was shaking, and what would end up happening is since it was shaking, I was looking at it and looking at the reason why it's shaking is because it's out of balance. And if we could create an apparatus where we could control the out of balance, so it's always on one side, we could actually, by that spinning, would actually create a, as opposed to just a moving back and forth, it would actually create movement. And that's the whole concept behind propellant propulsion. So in the came up with that idea in the March of 1990, worked on it in the mid 90s, actually had some exchanges with Dr. James Woodward, I believe from, he's at Caltech Fulton. I think that was the university that he was with. And then also exchanged some stuff with NASA in the 90s. So nobody, the concept is based off of, well, let me kind of go a little bit next step. The concept is based off of Einstein's special relativity. So the idea of something being out of balance would actually be, the next step of it would be the faster that an object is moving, the more effort it takes to move it in that same increment faster. So, and up to the point where when you start, that's a whole concept where nothing can take all the energy in the universe, and you still couldn't get one atom to move as fast as the speed of light. Just as you move faster and faster, it takes more and more effort, more and more energy to push it faster and faster. But there's his equation, 1 over the square root of 1 minus v squared over c squared, tells us exactly what that equation can be. But kind of taking a step back from that a little bit, this was the original, this is one of my early designs. I think this came up in, like I said, about mid-1990s, that I was kind of playing around with different ideas. And actually, at one point, I was working on getting a patent, and that might have been actually after the year 2000, the early knots, to get a patent on this, and actually went through all the work, paid a bunch of money. It never actually got filed. I was getting very frustrated. We won't get into that here. Something that was supposed to be done, filed in 10 days. 3 months later, they still hadn't, got the paperwork together. So I dropped that and went on with my life, and just continued to work on things on my own. But anyways, this is a video to talk about kind of that basic concept. So you have the central ring here, and that's fixed in place. And then you have these other gears that actually go around it. So I'll show you just real quickly what it looks like. So you can kind of see that the center ring stays, there's actually an apparatus which causes the rings to actually spin as they go around. Now, I don't know if you can actually tell in this, but there's actually weights on here. If you look here, there's a weight here, there's a weight here, there's a weight here, and there's a weight down here, right here. So, one of the things that you can do here is, as it makes a revolution, so one thing you'll notice is that weights up here, down here again, down here, and down here. So the interesting thing here is for this to turn 90 degrees, like that, the distance that this weight right here travels, it only goes from here to here in that distance. But on this side, we have a weight down here and then a weight up here. So velocity has to do with time versus, our distance divided by time. And so if you're going here, the speed is actually going to be much slower for this to go to here than for this one to go from here to here. But they're on a fixed apparatus here, so it's going to be constant. just the same thing. So every time it's going to take more effort to go, and let me go around this way. So every time it's going to take more effort, this one's going to go here, which means it's going to, the faster it moves, the more mass it has, per Einstein's special relativity equations. And so if that's the case, that it has more mass, it's going to take more effort. And so it's going to actually be pushing, the apparatus is going to try to push down, which means it'll actually lift it up. So if you get this spinning fast enough, and now the thing is you'd have to have another one that to counteract the spin, the spin. But basically it's just the same thing. As it pushing it in one direction, you'll get an opposite, equal and opposite reaction in the opposite direction. So that's the whole concept behind this. And then just real quickly, I did actually hook up a motor here. Just to kind of show you what it looks like. And the idea is that you spin it faster, 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 faster. The metal weight's going this way. This time that's just moving a little piece over here. And so it's going to take more effort to move that weight, move that weight, move that weight. And basically that's how I get the out of balance fan blades. Hopefully, all right, I will go ahead and end the video here. Thank you.